So, hi, Romain. Did I actually pronounce your first name right? Romain?
Yeah, almost. Actually, in English, you can just say Roma, like forgetting about the end. Yeah, it's close to the way we pronounce it in French.
So, what was your first computer?
I think it was a Median, close to our actual computer. It was an Intel CPU, etc. I got it pretty late, at something like 18. So it was not an Atari or an old computer.
And why that late?
I don't know. I was not interested in computers at the beginning. And actually, I got one to
and
do
what you started
lithography.
with? So you got your computer with 18. So what was your first, task with the computer? So what you did first? You played games or?
I think it was starting to play with pictures. The first thing I got was a scanner. So I started to play with
PaintShop Pro, right? Yeah, I also played with scanner. Yeah. And what happened to me is I was able to scan, incredible large files. So back then, so I scanned, I don't know. I forgot it was like, one page was like 200 megs, just, choosing the wrong resolution. Yeah. And what you did with the PaintShop Pro? So you were like, so you did your layout or design? What was the idea behind?
I think the first thing I did was nothing. And then it was, I started to draw a bit, but I'm bad at that. So it was mainly, photos and things like that. And then I did some 3D. So I was using it to do some matte painting.
Okay,
so
but night painting?
Night painting.
Okay, and
night. Like doing a background for a scene.
And why you did it? So what paintings were they? Like, science fiction or what was your motivation?
Yeah, it was to do some SF and to animate some things I modelized in 3D.
How you started? So what was your first program, or why you started programming? So
because when you start to do 3Ds, you are animating things, and pretty quickly you need to do some coding. It's not like Java or what we do at work, but you need to code. So I started to automating things, and then I entered
which
into
programming language was it?
I don't recall. It was something specific to the software I was using. It was Cinema 4D.
Okay.
I don't recall the language.
And do you have also some experience with Maya or?
No, because it was super expensive and hard to find at that time.
Okay. And what was the most important thing you animated? You have it still somewhere on YouTube or YouTube? YouTube.
It's not public because at that time I didn't have internet, so it's all local. But I think it was a 3D car moving in my street.
And what was the most impressive thing you animated? So was this your car or what? What was it?
I think it was a small Diablo. I did a small movie because at that time I wanted to enter into photography schools. So I did a small movie to be able to show my work and
you managed
to enter into the school.
And you were successful with the strategy?
Not really, because what I didn't understand at that time was you need to be able to draw and very well to enter into these schools. And not just be technical.
As always, you have to also self-market yourself and Okay, yeah. So what was what were the next steps? So you were not that successful with your school. So what was your thinking then?
So then I moved more into programming. I started to learn C language, then GTK. So then I went to a school where programming was not the main skill. And I realized at that school where we did a lot of C, that I like that and I want to do that at work. So I switched of school and went to a real engineer.
Was it a school or university or what is it? Okay.
It was
in France?
Yeah, the kind of school we have only in France. So it's equivalent to the university, but it's not as open as the university.
So
It's still
I
school.
think we have something in Germany as well. It is not university; it's more like applied science. So it is university is more theoretical, and the applied science university is more more pragmatic, I would say. So you learn actual programming. In the university, you also learn programming a bit, but it's more theoretical, you know.
It's the theory as well. This kind of school.
And applied sciences in Germany, we also have theory, but the theory is like, you know, I don't know, 1-2 semesters, and then you start hacking coding, and you have also a practical semesters, not just, you know, theory. Yeah.
Yeah, it can be close.
And so you learned then C for GTK. So what's interesting? So GTK is Linux. So at least I'm aware, mostly Linux and C. But you wanted to be, you know, infographics guy. So I would expect more, you know, like Apple on Windows. So why you stick with Linux?
Because Windows was proprietary, etc. So I was already sensitive to open source. So I was using Linux, and actually the fun thing is my first program with GTK was a picture program,
Cool.
a small paint. That's mainly because Windows was proprietary and was not customizable. You know, at that time for me, being able to have your own environment and on Linux was something very important, something very customized and adapted
I also
to you.
used Linux from day one for other reasons. So I always wanted to be programmer. I never wanted to be like, you know, graphic designer. But what I know a lot of graphic designers, and they just don't care about openness. You know, they take the right tool for the job and they're happy. So this is what makes me curious. So your background is more like infographics or graphic design, and you still wanted to be to have an open operating system. This is what made me curious.
Yeah, but don't forget with open source, you also get the free side of the software. So you get a lot of software for free, whereas on Windows you need to buy.
So now I get it. So you did it just to save money, right? Yeah.
I guess so. I'm not sure it was intended, but I guess
this was actually my case because as I was a student, I wanted to have free compilers and the whole programming environment. And I knew if I buy Windows, I could just buy the student stuff. What I actually also did, so I bought, you know, the whole. It was not .NET. It was from Microsoft prior .NET. I forgot the name. It was J++, C++, and the other stuff from Microsoft. And I got it extremely cheaply as a student. But, you know, in Linux, it was not a big issue. I just downloaded the compilers and was able to do whatever I liked. So this was why I really liked Linux back then. So cool. So then you started serious programming with C, GTK. Okay, and what's also interesting, you mentioned you built an image editor with GTK and C, but this is also lots of math involved, right? So for all the filters and you did how you got into the math. So how you got the algorithms?
Well, basically the picture algorithms are very well documented on the internet and not very hard. Actually, it's kind of mathematics, so nothing very hard to get. So I just picked some papers on the internet and implemented that. And my goal was to implement, I don't know if you saw it, but in Photoshop you have a mode, very advanced mode, where you can get a small pop-up and you enter the matrix of your filter. I think there is that in GIMP now. And it was my first goal. So being able to configure a filter and apply it to the matrix of the picture.
So I also did some, metrics stuff. I tried to use it, I think, even for encryption back then, but this is hard math stuff. So it's impressive that you were able, to read the paper and implement a C code, which realizes the paper. So cool stuff. And what was your next project with C++, or C?
The next one, serious one I did, I learned in between Qt, so it was C++, and I did a music player. And the motivation was, so I was looking for a software like Winamp. I don't know if it still exists, but being able to handle my library of music. And I didn't find anyone at that time, so I just did a custom one with.
How old were you back
SQLite.
then with the image editor? You remember that?
I guess I was a bit before
That's
20.
incredible. So you actually went from non-programmer to programmer in 1.5 years around, and you were able to read, research paper or algorithms and convert them into C code.
Yeah, but I'm not sure it was good programming. I mean, it was working, but at that time I didn't fully understand the event loop of UI programming and things like that. So I was doing things probably bad.
Sure. No one is perfect, but it's still remarkable. Okay, cool. So music player, did it work actually? Your music player?
Yeah, it was pretty good. I think I used it for 1 or 2 years, and then the mainstream players caught up, so I just switched to a mainstream one. Because, if I get back the code of one of these two programs now, you can't compile it anymore because the compilers evolved and some syntax is no more
It's getting more and more impressive, so I'm really curious about your third project. So what was it after 2 years? What do you build then?
Oh, it's a good question. I guess then it was no more personal stuff because then I was in engineer school, so it was the school projects. That's a good question. I don't recall what I built but it was more scheduling and things like that because my school was in these topics, so it was not UI or
you said
something
scheduling. Okay, so it's probably you built something like Kubernetes Lite back then, right?
It's more about scheduling problems, so you try to optimize the function, things like that.
So, was it anything interesting between C++ in your next programming language, or you were basically done with the two projects in C++ land?
Yeah, I think I was done with C and C++ at that time, and I needed to switch to Java because it was kind of enforced by either the school or then the work. And the fun thing is I was missing a lot C or C++. Because in Java you can't manage your memory anymore. And it was something very shocking for me, at least at the beginning.
So, this is funny, because the first time you were forced, to learn C because you're, by the market, basically. So you were very good with technical skills, but not by market yourself. So were forced to use C, and now the second time happened with Java, right? Because the market forced you to learn a new language. And you enjoyed that? No, you said there is no memory management. What else you missed in Java?
I think it was more a feeling than something I really missed because I was able to do what I needed, but I was missing the full control on everything, But then I started to do some Spring, and it was actually nice to be able to do everything very, very simply, to not have segmentation faults or things like that. So I started to find Java convenient, let's say. And then I started to work with Java and learn a lot of E stuff. And it was it's very powerful because you can do everything and you can do a lot transversally without having to code it. So it's what I really like with Java.
This is really interesting road because you started hardcore algorithms in C and C++, and then you learned Java. So what were the first project with Java you did?
It was a scheduling problem solver, like optimizing. I don't recall. It was to reduce the cost of production chain.
So this was a commercial project, right? So you were paying for that. So you already worked for a company.
It was at school, and it was a partnership with the company.
And then after your school, what you did then with Java?
Yeah, so the first thing was working with Hazelcast, which was nothing at that time, and now it's something something big. The goal was to process on a grid some big files. So it was kind of big data without saying it is big data. And distribute the computation.
I don't know whether you were involved back then. I'm just searching on my blog because it was probably 10 years ago. And the guy from Hazelcast was, what was the name? Tulip, right?
Yeah.
And he asked me, this was 2009, and he asked me about Talib, not Tulip, Talib Osturk. And he actually, this was, I'm right now reading this in March 16, 2009. And he asked me now whether it is a good idea to make Hazelcast open source. And we had a chat. Yeah, this is really funny because I remember this right now, and I'm just on the comment. I will put it in the show notes. And we had some conversation, and I say, absolutely. I mean, this is the way to go. And yeah, 2009. This was 11 years ago. Were you involved 2009 with Hazelcast?
No, because I started that in 2010, I think.
But it was already open source as you started, right? Okay, interesting. So it seems like it happens in between. And the Talib was really nice guy. And I said, okay, Hazelcast. And I was a little bit, skeptical because how one guy can create, a distributed cache, which actually works. I mean, this is lots of effort. And for me, was like, okay, some student hacking something. And Hazelcast become really big here.
And the fun thing is, when I started this project, it was not supposed to be Hazelcast. It was supposed to be GridGain at that time, so Ignite now, and combined with Infinispan. And I started to do the implementation. I actually did it. And Infinispan was not working at all. It was not handling concurrent accesses and things like that. So it was just completely buggy because it was kind of new, I think. So after 2 weeks, I just said, okay, I switch off library and I'll take this one. And Hazelcast was seducing already because it's using the Java API. It's implementing in a distributed fashion Java API. So it's kind of, for free, you get the distributed behavior. So it was really smooth to integrate it and implement the software.
Actually, probably you were in the unlucky situation where the Infinispan was rewritten because I use JBoss cache and it worked before. And the JBoss cache had two modes, like, consistent mode and scalable mode. Like basically you could specify the isolation level. And it worked, but it was a tree. And then Infinispan was rewritten from the tree to a map. And probably this was the time where you tried to use Infinispan and it didn't work, because right now it works very well, actually. Yeah, and what you did actually was that? Was the cache, you needed the cache for what? For calculations, or what you did with that?
So the software was pretty simple. The first phase was to load all the file in memory to ensure all the data are in memory in the distributed grid, and then to execute the computation per node, so with local affinity. And then there is a reduce phase where we get a kind of aggregate of that.
So map reduce is almost like a word count, right? What you did then? What was the algorithm, or what was the use case for that? Can you tell it so briefly? What?
It was to get, so the evening the banks are generating a very big file of all the transactions of the day, and the algorithm was processing all these transactions to check they were first valid, and then to try to detect if there is some wrong patterns in the transaction.
Funny story. Like you said banks, and this was several years ago. A bank. So I was in a project there, and someone asked me from the bank, we have a big data, and we need to perform some computation. Which framework to choose? And I say, how big is the data? I was like, this is like 50 megs or 200 megs mega XML file. It's like, okay, this is not that big. And what we did then, as a proof of concept, we just loaded the entire XML to a concurrent hash map and performed with Java 8 streams some basic calculations on it, and we were done. And they wanted to start, multi-month project with frameworks to evaluating the stuff. And at the end of the day, the guy wrote this by himself, just, reading everything to memory and doing stock Java 8 stuff.
Yeah, I think I did something very close for, when you ingest the data to populate a reference database. So if it is, let's say you are using JDBC to populate the database, if the data are not moving a lot, so if everything is moving, you just ingest everything, and one by one in streaming, and that's it. But the case I had was every day you get a new file with everything, but actually only 10% is moving. So what you want to do is to only modify these lines. And the way we did it was to load all the data in memory from the database and the file, do a diff in memory, and then generate only the queries or statement for the modified lines. And it is pretty efficient to be able to load everything in memory. And actually, the big data is exactly the same paradigm. It's just when it is about huge amount of data. But it's quite late,
exactly.
Actually,
so you can fit an amazing amount of stuff into a single machine memory. And this is the easiest way to go before you start to thinking about distribution, actually. And by the way, recently, this year, I was lazier. And what I did is I loaded the data, exactly the same use case you were telling me about, into memory, and I misused JSON-P, to compute the diff. And then I knew, okay, did something change or not? And with the diff, you can apply it, and you have, you can merge this. You know what I mean? Yeah, this was actually a cool hack. Yeah, cool. So was it already Java-E back then, or J2E, or something?
So for this work, it was almost Java standalone. The ecosystem was Spring integration, Spring Batch. But we were moving out of it and just using kind of streams. But I think it was just when Java 8 was starting to be something. So we were in between, so it was a kind of custom
out from
streams.
Spring?
Because it was over complex for the batches we were doing.
You mentioned one time that you started with Java-E. So how you started with Java-E then?
Yeah. So I was in a transversal team in that work. Responsible for a part of the runtimes of the company, and my team was involved in Apache openEJB, so what is Tommy now. And actually my direct manager was a committer already in Apache openEJB. So it just kind of mentored me and helped me to...
So you were forced again to use EJBs, right? Yeah, and who is your manager? Who was your manager? And you like the openEJB experience or not? So what's...
Yeah, I really liked the fact... so at that time, Java-E was EV and all negative things you can you can want. But the philosophy was to say, okay, what's EE at the end? EE is just about some programming model. So, and why should it be EV? And the philosophy of Apache openEJB was to say, let's just stick to the API and implement it without all the boilerplate and EV stuff. And actually, openEJB was the first embedded container. It was at that time a Spring Boot already, a EE boot. And it was very, very nice to work with it because you can write tests directly. You don't need to do unit tests, which are pointless, and integration tests. You can directly do tests for your code. And you can even bundle a custom main like we do today with Spring Boot or Quarkus or whatever, and just launch openEJB in the main. So it was really the philosophy I liked. What you code is what you can deploy. And of course, if you want to go into production with the standards of that time, so Tomcat, you can deploy openEJB into Tomcat and get a EE container, but it's not required. And it's really the
exactly. And funny enough,
I
I just look at my blog post. This is from 2009 again, June of 2009. And what I wrote back then is how to unit test EJBs in 0.8 seconds. And what I did, I use two lines, like, properties, new properties, then properties put, and then was org Apache openEJB client local initial context factory. And you could look up the EJBs and just use them in a main method, basically what you said in a unit test. And it took 0.8 seconds 11 years ago. And this was incredible. So back then I misused openEJB for more complex integration tests and look at the code. And it looks like Java E5 back then. So it was even prior, the Java E6 and CDI. Yeah, it was cool stuff.
Yeah.
So and then you started to like Java E, right? If you saw the openEJB, this was basically you wrote to to become a commit as openEJB commit as well, I suppose.
So Jean-Louis helped me to contribute the bin validation integration in openEJB. And then I started to be a committer, then a PMC. And what's nice with this project is it's the E container at the end, whatever mod you use. So you are working with a lot of specifications. So working in openEJB, then Tommy, I worked with bin validation with JBatch, JCache, GBA, etc. So I started to learn a lot of things because I was still a new Java developer at that time. I started to learn a lot of things and become very technical and to build transversal integration because keep in mind it was still my work at that time. So to add all we have today with micro profile for Kubernetes, so monitoring, tracing, standardization.
Okay. When was it with your contributions to openEJB?
I think it was in 2011.
Okay, so it's still a long time ago. So and what company was it you mentioned you worked for? And what was your what were the use cases you were solving with the technology?
So we were providing the E runtime for other projects, and we were instrumenting the container for the
but
production
what the
needs.
company did, so what was it? Is this like e-commerce?
Oh, it was online payments.
And those
things like
are
that.
you had to to be scalable, so many transactions per second, or what was the environment?
But at that time we were still installing the instances manually, like having a real computer, bare metal.
Yeah.
And
This is also what still happens in some companies. So this was 9 years ago, so it was natural. What you did then? So you started to contributing all the stuff, and then you swapped the companies, or what was your road to now?
Then I went to an online bank in Switzerland. It was mainly integrating reference data for the company. That's where they started to no more use Spring, and we were starting to build a kind of custom framework for the batches and streaming. The streaming being to get real-time data.
And you also contributed to Spring? You are also Spring committer? Why not?
No,
I mean, if you contributed to Apache, you could also contribute to Spring.
It's not exactly the same because at Apache, I contributed a lot to either standard stuff, so implementation of E, or transversal stuff. I'm thinking about Apache Sirona, for instance, which was the monitoring solution. The common point between this project is it is not impacting your code, your business code. Whereas if you work with Spring, it is directly impacting your code. So I think I like the fact I can stay focused on the business code when developing a business project, and still have a stack with a lot of feature I can activate or not depending the use case. So I guess that's why I didn't do much Spring.
So you prefer Java over Spring. So why you did the Spring then in Switzerland? So you could just stick with Java, right?
Yeah, it was the standard there. So there are areas in the world where you use E, and some areas you are using Spring. So Switzerland
you were
is
forced to use Spring again, right? So this is your whole career was just external forces forcing you something to do what you didn't like.
If you want, but it was not.
And how long you stick with Spring? And then
10 months. And then I joined Tommy Tribe. So I was doing back some Tommy stuff and.
Hey, cool. And then Tommy Tribe, you hacked the Tommy server or did more consulting?
It was mainly extension to Tommy server.
Which extensions you built?
To be able to be. Yeah, so it was. We can summarize it very shortly, saying it was micro profile before micro profile. So it was monitoring. It was. Gateway, it was API registry.
And you enjoyed that part more? Like that. So was it like now your dream came through, or you missed something?
No, it was pretty interesting. It was also very nice because the team was composed of Tommy committers, so it was weird in one way because it's like working with friends, and it's not always a good idea to work with friends or people you like, but
and you stayed with
really
France
nice.
the entire, or you moved to? Okay, cool.
Yeah.
Okay,
yeah,
and how long do you stick with Tommy Tribe?
Okay, years, I think,
okay.
Like
So
that.
no, where did you actually left Tommy Tribe, and then what happened then?
Okay. Then I joined Talent to build an abstractions framework for their component. So basically, the business goal is to build pipelines or batches, things like that. So it is composed of components. And the challenge Talent got some years ago was they had the legacy standalone studio, which was a generator of pipelines. And they are moving to the cloud a lot. And the cloud for them means UI with in JavaScript with React, and a backend with Apache Beam, which is an abstraction on top of Apache Spark, Apache Flink, etc., all the big data engines. So the challenge was to be able to write the component once for both environments. So it means you need an abstraction for the UI between SWT, which is the Eclipse framework, and React.js, and an abstraction for the backend, which is either standalone or big data. And it was my job to build the framework.
Okay, and the company name was Tenant, you say? Okay, cool. And you are still at the company right now?
Yeah.
Okay.
For 1 month.
And then you are leaving again? And can I ask you which company, or is it confidential?
The company does not exist yet, and I don't know the name yet, but it will be something around.
Cool. And this is will be going to be your company? Okay. And
no.
So which technologies do you choose? Something from Java or MicroProfile, or you build something from scratch again?
It will probably be based on OSGi. And in particular OSGi CDI.
Okay.
So kind of both. Because it's the more adapted for.
But right now in Tenant, what are you using? Are you using right now CDI as well?
It depends where. So the core of the runtime is something custom, because the only drawback of CDI is it is global. It is even if you can specify what you are scanning with SE API or whatever, it is global for the whole JVM. And it does not work well in big data where your instances are serialized, etc. So there is something custom for this runtime. But for the website, so the backend of the backend of the backend of the React.js front, it is close to a microprofile server. It is using microwave and a lot of Geronimo microprofile implementations.
And you say React. Is it React.js? Okay. So why you choose React on that plain web component? So in all my project, we're just using plain web components with ES6.
So it was not my choice.
Okay.
I guess because so React was the fastest. And there are it is about data. So there are several use cases where you need to render a lot of data and be able to be reactive if some data are moving or are recomputed. And it's hard to make it fast. So typically Angular was not an option for that use case.
Mostly true for everything. Okay.
Angular is not that bad, but so Angular was not an option. Vue.js was not something at that time, and web components were, I guess, are still not mainstream enough because you can do the rendering pretty easily. It's pretty convenient, but the challenge in an application is not the rendering. You can do it. You can even do it with plain HTML. The challenge is the management of the state. And with web components, you have nothing. You need to rebuild
what I do in similar cases right now, we use custom elements of web components with lit HTML. So we get DOM diffing for free and Redux for state management. And the architecture is almost identical to React, what I did prior, the web standard. So it actually works extremely well.
I believe you. It was not my
problem.
choice, so I can't really.
Just discussion. I was just
it.
interested in your opinion, just to chat with someone, because I'm a consultant and I get questions from my clients, and I'm just would like to provide somehow how it's called balanced answer, and and for now the web components in the new projects, and I did React 2-3 years ago, and now my projects from the source code perspective and performance are almost identical. So this was why I was curious. I assume your project is older, and 2-3 years ago you didn't have so much choices than now, right? So now you could do something else, and back then React was the right choice. So
so there are two things interesting about what you just said. The first one is it's likely part of the applications will be, I don't think the old one will be moving, but the new one will probably be in web elements. And the other thing which is interesting is so they are using Redux, and it will probably be dropped because the issue with Redux it is global, and so you have a single big hash map, and what you want is to have submaps. So if you want to do it with Redux, it's doable, but you need to have a convention and use it in all your controllers components, depending on how you architecture your code. What's interesting is to move to something closer to Angular 1 with services where you can have state per area without having to have a convention in a global store. And I guess it is what
and this is what I never got. I really like Angular 1. So for me, Angular 1 was very interesting framework. And Angular 2, I have no idea why it even exists. So this is like, this is if we were bored in the backend and we will move all our APIs to the front end, I use dependency injection modules, and in Angular it is really bad. And the problem is also that it moves too fast for most enterprises. You get 2 releases a year. You have constantly watched the changes, and React is just far more stable. There are not as many frequent, changes than comparing to Angular.
I'm not sure, because they just moved to old deprecating all the APIs, so it's still React. The version didn't change, but you still have to rewrite some code.
This was with the hooks and the suspenses. This is new stuff, but it was stable for years. This was the first, major change, I would say. But interesting, and Redux, you are right. So you have one central store. What I usually do, I combine reducers. So it means you can have slots in the hash maps. You can have sub hash maps. This is what makes it a little bit easier. But it's still one single store. You're right.
Yeah. So the issue with that is, if you have a single application, that's fine. You are the god of the application. You do what you want. But if you have multiple applications, and think microservices, each team will want to contribute some part of the application to the whole application. There is no more convention. So it's hard to still use Redux. And that's where you need something like services.
Yeah, you would need something like, so you're talking more about like micro frontends where you have multiple independent parts, which, good solution would be, if it would be possible now to ship every micro frontend with an own Redux store and communicate between micro frontends with custom events. Something like this could work.
Yeah, to redo the portlet in the front. Yeah,
great. So so in the backend you need OSGi. This is what I don't get, because you would like to run everything in one JVM, or why the idea with the OSGi?
You don't need, but it has several advantages. So first, you can dynamically redeploy something. It's not always needed. Typically, if you just have controllers for a front end doing some queries in a database, you don't need that. But if you have very long processing, you don't want to stop the processing because you add the feature to a container. So it's a good thing to be able to deploy, to redeploy something. You also have standards you don't have in E or micro profile, or let's say the standards are not yet mature. I'm thinking about the configuration, for instance. OSGi has config admin. Microprofile has microprofile config, but it's still moving, and the design is not yet as mature as concurrent. I'm thinking to Delta Spike, for instance, which is more stable and way more featureful. You also have the isolation. So if you need two libraries in different versions which are not compatible, you can make it work. It's interesting when you are deploying multiple teams binaries into the same container to optimize the memory and resources, because Kubernetes is not helping at all with that. It's just expensive. And you have the whiteboard pattern. The whiteboard pattern is, to simplify it, you register services in the global OSGi registry, and something else is consuming the service. And it is really central in OSGi. You can do it in CDI if you want. You have a registrar or whatever taking services, but it's not done. It's rarely done. And being central in OSGi, it means it's trivial to switch from a local to a remote services. So you can start small with a single container with all services, and if you need to scale like crazy, you can distribute the microservices very easily. So in terms of scalability, it's really smoother to be based on these patterns than using microservices with flat microservices.
And you are doing this right now, or this is the idea for the new company?
No, it's just something I'm starting to test, because so OSGi CDI is the integration of CDI in OSGi is a standard, and it's pretty recent, and I helped to implement that, at least the support of openWebBeans in RES implementation. So I'm starting to play with it, and I think it's really the most adapted solution for microservices today.
Now the discussion starts to be interesting. So in my projects, I'm not using any modularization, OSGi or JPMS, Java Platform Module System at all. And but this is, I think, complete different use cases. So what we are usually, what I'm doing is usually enterprise or business projects, and we are shipping, I would say, probably 10 microservices at most. And back then it would be a viewer wars, and now our 10 microservices is usually a war, and every microservice is considered as a self-contained war. So the modules are wars, or in Quarkus are jars, and they are communicating with each other. So either via synchronous REST, asynchronous JMS, or sometimes we don't have database and there is a Kafka or Pulsar or something. And there is absolutely no need to have further modularization inside the wars. So the wars are just, we have nice packaging, nice Java packages, nice names, and that's basically it. I think in use case, what you are doing, you say, okay, the modules, the wars, they will just run on single JVM, and I isolate the thing by myself. So it's even more optimized solution than Docker, because everyone would run on JVM. Is this correct? Something like this?
Yeah, it's that, and compared to, so you can say Tomcat is a single application, and it's EIR. And so it's close, but you consume a lot more memory because you duplicate a lot of classes, whereas if quite often you have the common stack between all wars, so you bring the same classes. And here it will be optimized because it is a class loader graph instead of a tree. And you are communicating between wars through HTTP. Whereas here with the whiteboard, you will be communicating locally, and the API will enable you to be either local or remote. And that's really more powerful and optimized in terms of performances.
And you would to scale the JVM, if you would ship, two or not scale, let's say HA, high availability. So you will have to deploy 2 Tomcats, let's say, with 2 wars, but then the 2 servers will they have to communicate or not? No, because we have load balancer up front, right? So the idea would be you have 2 wars with the entire microservice graph inside a war, and the load balancer will balance the load between 2 Tomcats, right? Okay. And what is your clients or use cases are? It's just your idea right now, or you have concrete use cases for that?
There are some use cases, but I can't speak about that.
Okay. Because I see the use cases are if you would build a platform. So it means you build something, you told me about your algorithms and data mining or whatever. So you could build a business platform and ship on the fly the algorithms to the platform, which are versioned and machine learning, let's say. So you have machine learning data model algorithm today, and because of fraud detection, you get a new model tomorrow. This would be a use case because the data model, the machine learning algorithm would be just a jar, which trained model is versioned and could be loaded, deployed on the fly to your platform. This something would work, right?
Another use case. So we don't use that exactly like that today, but at Talend, so we connect to the data of the customers because we process them and we work on them basically. And the architecture is to say we have a Talend cloud, which is all our application, and we have what we call a remote engine. So that's let's say to simplify, a Docker compose multiple services. The customer is installing in his VPC. And in this VPC, if you put OSGi, we are able to send updates to the remote engine and ensure we are working with the cloud, which is a single version because it is our application. Whereas if you don't have this kind of infrastructure, you need to restart the remote engine or ask the customer to do an update. Well, it's not smooth. Whereas with OSGi, it is pretty smooth to do that.
The use case I would see if you have something like a partial updates. You say, back then, what I misused Naso and JavaScript or Groovy to, factor out algorithms which change frequently to avoid, the full restart. And what you could do with then is say, okay, doesn't have to be JavaScript or Groovy. I just, can hot load an OSGi module. But the problem is, let's say the OSGi module will load in 1 second. What happens with the in-flight transactions in this second? You have a solution for that? Okay, so you can swap it immediately. So I mean, not immediately. So the old module is available, and then the new module is available as well, and then you can just swap that, also reroute the traffic to the new module, and then you will kill the old module. Something like this.
Yeah, that's it. That's exactly like a load balancer.
Yeah.
But,
so what you actually build is like not Kubernetes rather than Kubernetes, Kubernetes inside JVM, right? Yeah. And how far are you with your research or even implementation?
I have some POC working. So I guess it's just a matter of making it
actually
industrialized.
Cool stuff. And how fast such a OSGi bundle starts?
It's comparable to starting a e-server, actually.
Yeah.
With the application, I mean.
This, right? We are full circle.
Yeah.
What you are saying here now, I talk about that, I don't know, 10 years ago without OSGi, because I never liked OSGi because OSGi is okay. The problem is how it was used, and it was mostly used with Eclipse RCP back then. And this didn't make any sense because what the projects did, they wanted to have plugins. And then, but there was no concept on having, different versions of plugins at the same time. So we had, to ship the entire Eclipse RCP with one version of all plugins. And there was, and then in some project, we even had to deactivate the plugins so that the users are not able to replace the plugins. So it was the total overhead of plugins with no added business value. And the next problem was in business project was the circular dependencies were not supported back then by OSGi. So we had to use the body class loader, which was like a hack because it just exposed everything to a central place. So every plugin could pick whatever the plugin liked. So do you have actually problems with the circular dependencies between OSGi modules?
The main issue I have with OSGi today is the tooling is not yet as mature as the alternatives. Testing OSGi container, you can use PaxExam, for instance, but then you need to have bundles. so it can't be Surefire, or you need the jar. Or you build it programmatically in memory, like with shrink wrap using tiny bundle or whatever, but it's a lot of work for nothing. So the testing is not that nice, except if you are using Eclipse, which is integrated with BMD, and then it is smooth. So that's the main issue. And the second issue is the ecosystem. Some libraries are not yet OSGi friendly. So you need to wrap them using wrap URL or to rebuild them. But it's not as bad as I thought, because I played with few libraries, HTTP client, several clients on different technologies, and they all work directly without doing anything. Whereas when I played with OSGi for service mix, so years ago, it was just impossible to deploy what you want. It was never working. You needed to rebuild the metadata each time. So it was a nightmare. Now it is no more a nightmare. Even Hibernate is working in OSGi now. So the ecosystem is becoming mature. What's really interesting is if you compare the specification, OSGi Alliance or EE, or even Microprofile, OSGi is really in advance compared to others, because they already integrated GPMS. They are building OSGi Connect, which is a way to make OSGi working with non-OSGi code. So they are really more advanced than EE, which is just
so what we can expect?
Today.
So in 1 year, we will get something like microwave running on OSGi, something like this? Or a microwave is the capability of hot swap, or you're building something entirely new?
Let's say nothing. No. So basically, today, if you take an OSGi container or even Carafe, you can add RES CDI with OpenWebBeans, for instance. So you have CDI. You can add PaxWeb or Felix HTTP whiteboard. So you have HTTP, and with RES Web Extra, you have the integration of a web servlet programming model. So basically, you have CDI, you have servlet, so you have and you had Jason, and you have a Microprofile 1.0 container already. It's already there. So I guess there is nothing new to build. There is no new container to build. The goodness of OSGi is either you use bundle Maven plugin to build a custom container. So you say, I want Felix with all these bundles. Or you use Carafe with its features to provision your container with all you need. So it's not about building something new. You don't need to build something new. You just use what you need with OSGi. It's really a different philosophy, which is really interesting and smoother for companies, because when you are betting on a container, you need to ensure it matches all your projects. With EE, it's almost impossible. The only thing you can do is to say, okay, all projects will have these features and will behave like that in production. With OSGi, you can ensure your container will match all use cases, because you can deploy anything you want.
But most of the application servers, like for instance, Glassfish and now Payara, they have OSGi built in. So, but they use it differently, right? So you could swap the EJB container or CDI container, but you cannot swap your application. So they are building. So they are using OSGi to separate EJB JMS from servlets, not to deploy new algorithms. And the same is with white flame modules, right?
Yeah, exactly. I think Liberty
is
OSGi. I'm not sure at which point it is.
Most recent OSGi implementation. But you could just use them right now and extend them. There would be a similar effect, right?
I guess so, except your application will not be OSGi.
And your point is you would like to have OSGi inside your application, right?
Yeah, because the first thing when I started to play with OSGi CDI was, okay, I want to get back to what I know. So using CDI, using servlet, using CheckService, etc. And after some tests, I realized you don't need to stick to what you know. You need to embrace OSGi. So I started to use config admin integration. There is a mapping which is way more advanced than with microprofile config. You can inject annotation, you can inject interfaces, beans, etc. already. And it's all backed by config admin, which is pluggable, so you can look into a database or whatever already. You can also use the whiteboard pattern, which is, it looks nothing when you learn it, but if you use it for all your key beans, it becomes very smooth to change the behavior behind that. It's close to, for instance, in Tommy for the remote EJB, we were able to plug different exposers. So we had an Asian exposer, we had a REST exposer, a SOAP exposer, etc. It's really close to that. With a whiteboard, you have a registry of service by type, and you can expose them as you need, and it's transparent for the bundle exposing the bin.
So, to summarize, you are no more a Java E and a microprofile fanboy, you became an OSGi fanboy, is it right?
I don't think so. I think it's more, I became a Java fanboy because I want both actually. If you look at RES OSGi CDI implementation repository, you will see that microprofile Geronimo implementation are integrated into OSGi CDI. So you can use microprofile with OSGi CDI and it can almost be transparent. So the way I'm seeing it is you can develop with whatever technology you like. It can be OSGi CDI, CDI, Spring, Juice if you want. But then the question is, how do you approach your deployment? Today what we do is say, okay, I don't care, I put all my thing into a Docker image and Kubernetes will manage. That's bad because it's very expensive to do that. With OSGi, you have simplicity to bundle and package it as you want, as you need. And you can save a lot of money doing that. So it's really something which you look into and not just say, okay, I put everything into a Docker.
You know what?
And that's it.
This is actually full circle. This is actually back to shared deployments, right? So back to shared deployment, to shared really isolated deployments. This is the issue because, this is what we did back then with ears, but there was no way to communicate between the ears. So you are using OSGi to improve the old ear deployment model with some additional capabilities like cross ears communication, stuff like that, right? Because back then there was class loader issues. The ears were too isolated, and you need, the true isolation, but you also would like to communicate. So this is your issue, right? So no, okay. Yeah, cool. Perfect. Yeah. So now, where people can find you? Do you have links to something you can reveal right now? And I would like to invite you in 1 year and talk about your invention once again. Probably it could be too long 1 year because you managed to implement a Photoshop and Apple Music in a few weeks, but let's see. In a few months, I would like to talk to you again what your progress is. But can you reveal something, some links and stuff like that right now?
So I'm on Twitter. So that's Hermani Bucco, and I have a blog. I think the link is on Twitter normally. .metaverse.net. And I'm regularly blogging about microprofile, and I'm starting to blog about OSGi too, and some random stuff as well. But cool. It's focused on IT.
So thank you, and I would like to invite you back in a few months. Perfect.
Yeah, okay.